Hello, this is Scholastic Sam. Welcome back to my YouTube channel. Today, in the class of trigonometry, in the topic of conic sections, we will be talking about parabolas. Now, the equation of a parabola. As we talked about before in my last video, which if you haven't watched already, on quadratics, you should watch that. Also, watch my one on completing the square, as that will also be important on converting between different equations. So we know the equation in standard form is ax squared plus bx plus c, and in vertex form is ax minus h squared plus k. However, the conic section form is y minus k squared equals 4p x minus h squared. Now, as we know, the vertex is h comma k, and p is the distance between the vertex and the focus slash directrix, which we will talk about shortly. Now, whichever one is squared, that's the one that 4p is not on. So if it's opening up or down, then it's going to be vertically oriented, and the squared is going to be on x minus h, and the 4p is going to be on the y minus k. However, if it's horizontally oriented and either opening right or left, it's going to be right and up if it's positive, left or down if it's negative. If it's right or left, if it's horizontal, then the squared is going to be on the y minus k, and the 4p is going to be on the x minus h. So let's look at the main parts of the parabola. The focus is a point p units away from the vertex in a straight line that's inside the parabola. And the directrix is a line p units away from the vertex, but it's outside the parabola. Now, if the focus is above or to the right, of the parabola, depending on whether it's horizontally or vertically oriented. If it's up or to the right, you know it's positive. If it's down or to the left, you know it's negative. Now, the line of symmetry or axis of symmetry is just the line connecting the vertex to the focus and keeps going straight. It bisects the parabola, and over that line is the parabola is symmetrical. The vertex, of course, is the center of the parabola. Now, P, when we talk about it, let's say you see something that says like 28x minus h. So we know it's 4p, so p would just be 7. That means that the distance between the focus and the vertex and the directrix and the vertex is just going to be 7. And that's either going to be up, down, left, and right, depending on its orientation. So let's look at graphing. Now let's take this equation to a graph. We see y minus 2 squared equals 28x plus 3. So we already see the y minus 2 is squared, so we know it's horizontally oriented. And we see it's positive, so, well, it's horizontally oriented, so it's going to be going left and right, but it's positive, so it's going to be opening up to the right. So we see that it's 28, which is 4p, so p is 7. And we know it's y minus k, so k is 2, x is negative 3. So the vertex, you plot your first point at negative 3, 2. To plot a parabola, you really only need 5 points. Now, the focus, so we know because p is 7, the focus is inside, and it's horizontal and positive. So we're going to be going to the right 7. So you go, since the orientation is horizontal, we know the axis of symmetry is going to be going left and right. But it's positive, so the focus is going to be inside to the right. The directrix is going to be outside to the left. So the focus is negative 3 plus 7 is 4, 2. And the directrix is negative 3 minus 7, which is x equals negative 10. Now we know the line connecting the vertex and the focus, the y value of both of those is 2. So we know it's y equals 2. However, if this one was vertically oriented, we would do the x values instead of the y values. And now let's analyze the domain and range. Well, we see the range is going negative infinity to positive infinity, but the domain is going to positive infinity, but it's not going behind negative 3. So we know that the domain is negative 3 to infinity. So what you do is, when you're graphing, we could just go 1 over 1 up and 2 over 2 up. because, or 2 over 4 up, because we know it's squared, and we know 1 squared is 1 and 2 squared is 4. But here, it just helped to plot like an x value that's either 1 to both sides, because we know if you go 1 over and 1 up on the left, because parabolas are symmetrical, you're going to go up the same amount if you go the same amount to the right. So if I go left 1 and up 2, then I'll know if I go right 1, I also go up 2. And this works for any direction. So then you plot 1 point on the left, 1 on the right. Because it's symmetrical, you can plot the same point on the other sides. And then you draw the arc pretty much, and you put your arrows at the end, you got your graph. Now, graphing part 2. Let's take this one, let's look at the graph, and let's find the equation. So we look at the graph, we see that the vertex is 1, negative 2. So we know, or is 1, negative 1. So we know that h is going to be 1 and k is going to be negative 1. So you know it's going to be y minus negative 1 is y plus 1 and x minus 1. However, we see the orientation is vertical because remember the focus is on the inside, the directrix is on the outside, and the directrix is down, the focus is up. So we know that it's opening up, and thus its orientation is vertical. So we know that the x part is going to be squared. So we know we have y plus 1 equals x minus 1 squared. But we know that 4p must go on the part that's not squared. So it's going to be 4p y plus 1 equals x minus 1 squared. Now let's look. We see the focus here, the distance between that is going to be at 1, 1, and the directrix is at y equals negative 3. So the distance between that and the vertex is just 2. So p is 2. So our final equation is 8y plus 1 equals x minus 1 squared. And as we look, the x value is 1 for the focus and the vertex. So we know the axis of symmetry is x equals 1. We see the domain is negative infinity to infinity, and the range is going to infinity, but it stops here at negative 1. In parabolas, either the domain or range, one of them is going to be negative infinity to infinity, and the other one is going to just have a limit on it. So please like, subscribe, turn on post notifications. If you have any questions, comments, or concerns, please leave them down in the comment section below. Thanks to my math teacher, Mrs. Barrett, for teaching me all this information. Please join us next time in the last part of our conic sections unit to talk about differentiating between conic sections. I'm Scholastic Sam. Thank you, guys. Bye.